previous video of kinetics, we have discussed rate of reaction. Today we are going to discuss rate law. When reactant converts into product, according to law of mass action, rate of reaction at a given temperature depends on the concentration of reactants. When you express this statement in terms of mathematical equation, you will get rate of reaction is directly proportional to the reactant concentration raised to the power x. So when you remove this proportionality sign, you will get a constant. So you will get the equation rate of reaction is equal to K into concentration of reactant raised to the power x. Here K is the rate constant and x is the experimentally determined quantity. When you express the rate of reaction in this form, this is known as the rate law. Let's study a little bit more about rate constant. Rate constant is the rate of reaction if all concentrations are set to unity. For example, in this above rate law, when you take the reactant concentration is equal to 1, you will get rate of reaction is equal to K into 1 raised to the power x. When you solve this equation, you will get rate of reaction is equal to K, that is the rate constant. Rate constant depends only on temperature. That means the value of K remains same for a given reaction at a given temperature. So let's see what does a rate law define. For this given equation, the rate law will be rate of reaction is equal to K into reactant concentration raised to the power x. Rate law defines how does the rate of reaction vary on changing the reactant concentration. Here, x is the experimentally determined quantity and it is the order of reaction. For example, if the value of x is 1, that means the order of reaction will be 1. If the value of x is equal to 2, so the order of reaction will be 2. If the value of x is equal to 0, in that case the order of reaction will be 0. But what does it mean if the order of reaction is 1? For this given equation, when you write the rate law for first order reaction, you will get rate of reaction is equal to K into concentration of A raised to the power 1. As we just have discussed, rate law defines how does the rate of reaction varies on changing the reactant concentration. So if in this case we double the reactant concentration, let's try to find out what will happen to the rate of reaction. This is the set 1 and it is the set 2. In set 1, we have taken the reactant concentration is equal to A. And for set 2, we just have doubled the reactant concentration. So the concentration of A will become 2A. Now solve the equation for set 1. So here you will get rate 1 is equal to K into concentration of A raised to the power 1. When you place the value of reactant concentration in this equation, you will get R1 is equal to K into A raised to the power 1. Similarly, when you solve the equation for set 2, you will get R2 is equal to K into reactant concentration raised to the power 1. Now place the value of reactant concentration. So you will get R2 is equal to K into 2A raised to the power 1. Now try to find out the relation between R1 and R2. So you will get R2 divided by R1 is equal to K 2A divided by Ka. Because we have performed the experiment under the same temperature condition, so the rate constant will remain same for the given equation. So here we can cancel out K with K and A will get cancelled out with A. So you will get the relation R2 is equal to 2R1. That means on doubling the reactant concentration, rate of reaction also get doubled if the order of reaction is 1. Now let's try to find out what does it mean if the order of reaction is 2. First write the rate law for the given equation if the order of reaction is 2. You will get rate of reaction is equal to K into reactant concentration raised to the power 2. So let's try to find out what will happen if we double the reactant concentration. So here is the set 1 and this is the set 2. In set 1, we have taken reactant concentration as A. For set 2, we have doubled the reactant concentration, so we can take it as 2A. Now write the equation for set 1. You will get R1 is equal to K into reactant concentration raised to the power 2. Now place the value of reactant concentration. You will get R1 is equal to K into A raised to the power 2. Similarly, write down the equation for set 2. You will get R2 is equal to K into reactant concentration raised to the power 2. Now place the value of reactant concentration. So you will get R2 is equal to K into 2A raised to the power 2. Now solve this equation. You will get R2 is equal to K into 4A square. To get the relation between R2 and R1, we are going to divide R2 by R1. So you will get K into 4A square divided by K into A square. As we have conducted experiment under same temperature, so the rate constant will remain same. So we can cancel out K with K and A2 will get cancelled out with A2 and you will get the relation R2 is equal to 4R1. That means on doubling the reactant concentration, rate of reaction get increased by 4 times. Now come to the zero order reaction. What does it mean? For zero order reaction, where you write the rate law for this given equation, you will get rate of reaction is equal to K into reactant concentration raised to the power 0. Let's try to find out what will happen if we double the reactant concentration. So here this is the set 1 and this is the set 2. For set 1 we have taken reactant concentration as A. For set 2 we have doubled the reactant concentration, so we can take it as 2A. Now write the equation for set 1. So R1 will be equal to K into reactant concentration raised to the power 0. Now place the value of reactant concentration in this equation. So you will get R1 is equal to K into A raised to the power 0. As you know, if any number, for example x raised to the power 0, it is always equal to 1. So if any number has 0 power, that means its value will be 1. So here when you solve this equation, you will get R1 is equal to K because the A raised to the power 0 means 1. Similarly, write the equation for set 2. So R2 is equal to K into reactant concentration raised to the power 0. Now place the value of reactant concentration in this equation. So you will get R2 is equal to K into 2A raised to the power 0. So as we just have learned, if any number has 0 power, its value is 1. So here you will get R2 is equal to K into 1. Now when you find out the relation between R2 and R1, here you can see R2 upon R1 is equal to K upon K. That means R2 is equal to R1. That means even on doubling the reactant concentration, rate of reaction doesn't change in zero order reaction. Now try to write the rate law if more than one reactants are involved in the equation. For example, in this equation, when A moles of A reacts with B moles of B and gives product. And you know, according to law of mass action, rate of reaction is directly proportional to the reactant concentration. Here A and B are the reactant. When you apply the law of mass action to this equation, you will get rate of reaction is directly proportional to the concentration of A raised to the power X and concentration of B raised to the power Y. Here X and Y, these are experimentally determined quantity. They have no relation with A and B, where A and B are the moles of reactants in a balanced chemical equation. So when you remove this proportionality sign, you will get rate of reaction is equal to K, A raised to the power X, B raised to the power Y. So this will be the rate law for this given equation. So what will be the order of reaction for such rate laws? In that case, the order of reaction with respect to A is X, and with respect to B, the order of reaction is Y. But the overall order of reaction will be X plus Y. For example, if the value of X is equal to 1 and the value of Y is equal to 2. So the overall order of reaction will be equal to X plus Y. That means you have to add the value 1 plus 2 and the overall order you will get 3. So as we just have studied, when you get the overall order of reaction, you have to add X and Y. And these X and Y are strictly experimentally determined quantity. So the order of reaction is also an experimentally determined quantity. It cannot be predicted on the basis of stoichiometric equation. That means A and B has no relation with X and Y, where X and Y are experimentally determined quantities and A and B are the moles in balanced chemical equation. Order of reaction is defined only in terms of reactants, not in terms of product. Order of reaction can be any real number. That means it can be 0, it can be any whole number, or it can be fraction as well. Now compare the rate of reaction with rate law. As we have studied in our previous video, rate of reaction can be expressed either in terms of change in reactant concentration with respect to time, or it can be changed in product concentration with respect to time. So for this given equation, when you write the rate of reaction, you will get minus 1 by A dA over dt, or it can be equal to minus 1 upon B dB over dt. When you express the rate of reaction in terms of product, you will get plus 1 by C dC over dt, or it can be equal to plus 1 by D dd over dt. That means rate of reaction can be expressed in terms of reactants as well as in terms of product. But when you write the rate law for this given equation, you will get rate of reaction is equal to K concentration of A raised to the power X multiplied by concentration of B raised to the power Y. Again, I am repeating X and Y has no relation with A and B. Because X and Y are the experimentally determined quantity, while A and B are the moles in a balanced chemical equation. As X and Y are experimentally determined quantity, rate law is also an experimentally determined equation. And rate law is expressed in terms of reactants only. It can never be expressed in terms of product. I hope now you understand what is the difference between rate of reaction and rate law. In the next video, we are going to discuss first order reactions.